So now it's time to see how to use big integer here. Now if you don't know about big integer, it's a class in Java and it belongs to a package java.math. And as you can see, this is the Java class and it has multiple features. You can have a bigger number to store, and it has lots of functions inbuilt, example for addition, for subtraction, for division, right? Again, you cannot perform normal operation between big integer and normal integers. You have to perform operation between big integers object itself. Okay, so before talking about all those things about operation, let's convert this int into big integer. So the input I'm taking is a big integer. The output I want to send here is again big integer, right? And then even this num, now you cannot compare with 0, right? Because 0 is a normal number and this big integer, this one is a big integer. So there are two ways. One, you can convert this number into integer, or you can convert this 0 into big integer. Preferably always convert the number into big integer, so that even if that num is a big number, if you convert it into 8, it will not work properly, right? So I will say big int. Okay, so we already have big int 0. So you can compare this number with a big int 0. So that it gives you a constant as well. So your job is done. And then you have to return 1. Now we cannot return 1 because 1 is a normal number. So you have to convert this into a big integer object, right? So you can, again, you have two choices. We can convert this into a class and then pass the parameter here. Again, you have to make sure that you pass the parameter in a string format. The problem is, this will not work. This is one way. The another way is you can simply say dot 1. So again, it gives you a constant for 1 as well. The same thing can be done here. So when we have 1, we can replace this with big integer 1 because we are working with numbers. We are working with big integer. See, the advantage of big integer here is we are returning a bigger number. Okay, now when you pass it also, you have to make sure that you are working with big integer, or instead of converting that here, we can specify this is a big integer. We cannot do that, right? We'll convert that into big integer. So we'll say big integer, and then we can provide a bracket in double quotes, of course. Yeah. So whatever input you have, you just have to pass that in big integer, and your job is done. So now this type of num here is a big integer type. I guess I've done my work. Let's find the factorial of 70 now. And if I'm running this code, it will take some time to run. Can you see that we got an output? Now again, as you can see, this is a very big number, right? You can see that it's a very big number. So you can find the factorial of 70 using big integer. Now if I make it a very big number, let's go for 700. Let's see what happens now. The moment you run this code, I hope big integer can handle that. Yes, can you see that big integer is also able to handle a 700 factorial, and you cannot imagine how big number this is. We don't even have a time to actually count the number of digits we have here. Let's go big. Let's make it 2 more zeros. And now this is ultimate one, right? Now if you can find a factorial of this number, then big integer is real god for you. So let's run this. Let's see what happens. So this is bigger than Hulk now, and oh, we got an error. Can you see that we are getting an exception now? This is your favorite exception. This is not null pointer, but this is a stack overflow exception. Now again, we all know about stack overflow, right? So when you create objects, when you call a function from a function, what happens is, let's try to understand what is happening here. We are getting a stack overflow error, which means that, see, when you call 5 into 4 factorial, what we are doing here is we are saying, hey, I will give you 5 into 4 factorial, but you tell me first what is 4 factorial. Then you say, okay, let me just first find 4 factorial. That means this computation is into stack, right? Then you are going for this computation where you are saying, hey, first find 4 into 3 factorial, but then 3 factorial will say, okay, first solve me. That means even this computation is going into stack. So you'll be having multiple entries in a stack, and of course stack has a limited memory, right? Or limited frames. So if you're going for 70,000 calls, you cannot have 70,000 frames waiting for you, right? And maybe it will work for some time, but after some time it will give you error. In fact, if you want to know how much time it will give you, so just before returning, what I will do is not here. Before returning this value, what I will also do is I will print a statement just to understand how many times it is able to call that, and later at what time it is giving you error. So if I print hello, just an hello, And then also let's also print the value for num. Let's try to understand what is the value it is printing. So if I run this code, you can see it is going. It went for a long time, and we got a fact error. Let's see till with what point it went. So it went for this number, which is 64988. That means it went for 64988, and after that it is giving you Stack Overflow, right? Still a bigger number, right? Okay. So again, it is out of sequence. No, is it out of? No, it is in sequence. So yeah, so after a long time, it is giving you a Stack Overflow, right? Even if you have a bigger stack, doesn't matter, right? We are getting an exception. Now, how to solve this? Now, what is the error here? The error we are getting here is because this for this computation, you need to first find 4 factorial, right? So till that point, you are not getting 4 factorial. This will be then in the stack, and every time you're going for the next value, it is creating a stack, and the frame is going up and up. What if you don't put this computation in pending? What if you can just solve this at the same time, right? So I mean, if you can solve the output at the same time, your job is done, right? So how can we do that? So we can do that using tailed recursion. Now, how do you do tailed recursion? That we'll see in the next video. So I hope you got the idea. What's the issue with normal recursion? Even if you're using big integer, you will get stack overflow. In the last video, we have seen int, where int has a limited value. Big integer has a bigger value, but then we have a limited stack frames. In the next video, we'll see how do you solve that problem. So I hope you're excited for the next video. Before going for next video, make sure you subscribe to the channel, because all this type of videos are on the way. And that's it. Thank you so much for watching.